Ladies and gentlemen, welcome on second Connection Wednesdays webinar for Idea StatiCa connection, circular hollow section joints in practice. Today we'll be presenting Mr. David Kučera and myself, Vid Hurčík. We are both product engineers and we will lead you through the webinar today. Just a quick recapitulation. If you want to type in a question, please do it in a control panel in a question tab where you can input your questions anytime during the webinar. Today we prepared for you a really nice example which we found in magnificent Switzerland in a really nice cable car, and it's a circular hollow section joint bracing, and it's really nicely stiffed by the end plates, and it's welded to a really small bracket, and we will go through this joint from scratch in the first part of the webinar. And in second part, my colleague David will show you two HelpDesk highlights. So let's jump right into the presentation, or sorry, into the real example. Let's say we prepared this construction or structure in some finite element analysis tool, and we load it in a Idea StatiCa BIM. So this is our new project. We have members, we have load effects, and we can start the design. For a start, I want to check out the local coordinate system because there is a little bit just small issue. You can see that there are no matches for local coordinate systems of these two pipes. So the first thing I will do is to check out my position of the member M3, and I will just rotate it in a way that my local coordinate systems will be matched. It will make my design easier for the future, and it will also affect the load effects. They are now in one direction. So let's start with the design. As you can see from, saw from a picture, there is a small bracket which will hold these two pipes, this bracing, and we will create it from general plates. I will start with a small general plate. It will be thin one, only 6 millimeters, and I will set it to member M1 to the bottom flange. It will be wider, not a doubler, and I can see it from this side, and if I turn on the transparent view, it's already here. Just now I will only angle it to the right direction and change the dimensions. Oh, it will be here, 0 and 160. And you can see that we started right way because the alignment is okay. And for now, I will turn off these two pipes just to see the whole work better. And let's continue. I will copy it and assign it to a different plate. Okay, it will be not rib but widener, and again I will just change angle, and you can see that I need to shift it in direction to the left, so I will change this position 55 millimeters. Right now we are missing a weld here, so let's add a new weld. Edge to edge will be useful for this, and we will add it to this plate, edge number 1, and to the member M1 top flange, edge number 4, and right here we have it, white one, sorry, yellow one. So next thing, we want to add a stiffener to the main beam, and the stiffener will be only 6 millimeters thick, and it will be on the rear side. How do you think we can adjust the shape in an easy way? Yes, we can add a stiffening, general stiffening plate and then cut it from all sides, but I think I can show you a little bit easier way. Let's go to editor and change the offset of the plate, but not the whole outline, only one edge, the edge number 2. And if we type in the negative offset, we will in fact increase the size. So that's a really nice thing, because we can add a material and then just cut it. It will be quick. Great. And just copy this cut and assign it to a different plate. And right now you can see we have almost finished with our bracket. There is only one weld missing, so just add it again. It will be edge to surface and a different plate, edge number 4, and member M1 top flange. Great. And here we have it, all things together. So that is our bracket, and we can again turn on our bracing tubes. So now it's time to start designing the connecting plate for these two tubes. So let's add it. Here we have the connecting plate, and we will assign it to member M3 for the start. And let me just change the type of the connecting plate, not to cup plate, but for notched member. That's better. We want to notch the member. And if I turn the view right, just like this, you can see that our plate, our connecting plate, is aligned with this M1, because this beam M1 is related to this operation. And this one, our connecting plate, is aligned with the longitudinal axis of the related beam M1. But I want to change the angle of this connecting plate, and I don't have option for that here in the parameters. How can I do that? Just easily, I will turn off the relation for member M1. Check it out. By turning this off, only one thing remained as a parameter here, M3, the main beam, and you can see that the connecting plate is aligned to one of these axes, which is great. In this position, we wanted to have it. So that's great. Let's turn off the local coordinate systems, and we can proceed with the definition. It will be 8 millimeters thick, and I will change a little bit dimensions. Sorry, there will be a semicolon. Great. And you can see I created a really nice connecting plate. So let's copy it and assign to other tube. And that's it. Only thing that is left is cut these two plates to connect them. Just one cut, this plate with this plate, and I will change the remaining part. Okay, copy this operation and change the assigned plate. Great. Now I connect it. And from my engineering point of view, if I will push through these members down, it will definitely make this stiffener to buckle. So I want to insert here a small stiffener too along this axis. So let's start. I will add another operation, another stiffening plate, and it will be only 6 millimeters thick. And I will place it to plate SP1, which is this one. And it will be not, yes, it will be rip, it will be to rear, and it's creating on the other side. So just rotating the view, and I need to shift it a little bit, let's say minus 100 to 20 millimeters, and adjust the dimensions a little bit. That's great. Let's cut it again. By cutting the thing, you will change the size, and you will add a weld, which is handy because you will do two things in one push. And I will copy this again and change it to the other side and cut it again. And that's the way I want it. That's great. I can turn all load effects, and I'm finished with designing of my joint. And that's great. So one more hint before we start the calculation or the analysis. We have a really nice tubes here, both of them. Both of them are divided in quite a lot of arcs. This is default setup, default setting, but if, oh sorry, I forgot the plates here. So we have to add a plates here and bolt it together. So that's another 2 plates more. So let me just add it. I will increase the size so we can see where the plate is and we can move it around. Now I will rotate it clockwise, just in one direction. And in the other direction, I will rotate it again, counterclockwise, like this. 85 degrees, nice. And now I will move it to the left and up. So to the left and up. And I have here a small fault. Great, minus 45 degrees. And if I change the view from the top side, you can see that we have this plate almost right in the position in the middle of these tubes. So I will move it a little bit to the left, only about 33 millimeters. And that's great. Now I will only adjust the position a little bit, so the dimensions. And if I change the view from the side, and then it will be 0 to 130. Great. And here we have one of our end plates, and I will just make a copy and assign it to this plate, and it will be a doubler. It will be a doubler without a weld, and it will be on the rear side. And that's all from the positioning. I will maybe move it a little bit further Okay. And now we have to bolt them together. So it will be 2 items, application, just fill it, and I will insert the bolts to -100 and 50 and 150. Great. And now the last thing, we have to cut our tubes here and here to weld them together with the plates. So cut of the member is handy for this, and we will cut member M3 by this plate, but not by bounding box, but by surface. And I will copy this manufacturing operation and assign it to a different member and different plate. That's great. And now it's done. And I talked about the division of the arcs. So once again, we have here quite a nice division of the arcs. There are a lot of them, but we don't have any intersection of the tubes together. So if you don't have any intersection of the circular hollow sections, you can change the division of surface of the biggest circular hollow member to smaller value, for example 32, which will help to speed up your analysis time, and it will save you some time in calculation. So I will turn it on. In the meantime, I have one new thing which is present in our presentations. I have a small poll for you. So let's just launch it. I prepared for you a small poll. The rotation of the member local coordinate system will affect only the manufacturing operations and load effects, and only load effects. Please vote right now. I will wait only a few seconds, and I can see that quite a lot of you just voted. Please do it right now. Great. Thank you for your answers. Almost 60% vote. I will wait a couple more seconds. Okay, so I'm closing the poll, and there is a result. The middle one was right. Yes, of course, it will affect the manufacturing operations and load effects too. So the B is correct. Great. So meantime, our results is here, and you can see that we have a problem probably here with the welds. So in a usual workflow, I will play with these welds and increase the throat thickness and calculate it again. And by this, this is the end of my side of the presentation, and I will pass the presenter to my colleague David. Thank you for your attention.
So hello everyone. Sorry, let me switch the screen. Yes, that's it. Hello everyone. In this part of our presentation, we would like to show you how to model stiffeners and doublers on circular hollow section members. Let's start with stiffeners. We can switch into the model in area StatiCa. This model is unfinished, and we can move on. In the first step, let's add inside stiffener. How to do that? We add a new operation by right mouse click. Let's add new operation, and it's stiffener, this one. The operation was added, and we have to set inside stiffener. So how to do that? Here is the trick. We have to switch the shape from circle to profile. And now you can see that the inside stiffener was inserted. Now we adjust the proper values for this operation, thickness and location. And that's it. We have inside stiffener very quickly. Let's proceed and add outside stiffener. We will use the same operation, stiffener. But this time we leave it as it is. Shape will be circle. We only set appropriate diameter and it's there. And of course we shift it a little bit to the position and set the thickness. And it's there. I can make connection or model for you. I can switch to solid view so you can see the whole connection. Just now we inserted two operations, inside stiffener and outside stiffener. And now I would like to complete my connection. We want connect this plate with outside stiffener. To complete our connection, let's add new operation. It's a cut of plate. And we have to select type of cut. Now it will be notch. And we only choose modified item. And this modified item will be cut by outside stiffener and switch to double-sided welds. And that's it. Notch was added. And the same on the opposite side. We want to do the same operation. So let's copy this operation and switch the plate on the opposite side. And that's it. Our connection has a final design and we can run the calculation. Meantime, we can skip back into presentation. So here is important to summarize three things. If you want make inside stiffener, here is the trick. The shape in operation stiffener must be selected as profile. If you want outside stiffener, you can leave it as circle. And if you want create a notch, it's hidden in operation cut of the plate, and you will select type of cut as notch. And that's it. Just now IDEA is still calculating, it's performing iterations, but in few seconds we will receive results. So now it's there. And as you are used to, in the on the left side of the screen, you can see summary of the results, and now you can investigate whatever you want in this connection. Do you need stress? So you can display stress. Or strain, whatever you need, or you can directly print a report. But we will not do that. So for now, I can close this first example. And we can proceed to the second example. It was a question from one of our customers, and he had 2 tubes, and he wanted cover one tube partly by the other tube. Unfortunately, directly it's not possible, but we found out a workaround how to do that. First of all, we have to create bottom part of this connection as a member, as ordinary member. So it will create our column. The second part will be created as stiffening member. And between these two parts, we will apply butt welds. So let's skip again into the model. This model is unfinished. We have the bottom part of the connection. And now we need add second part of the connection. Let's add new operation. For this time, it will be stiffening member. Let's adjust right position for this member. Let's rotate it a little bit and set the length of the stiffening member. So you can leave it as it is, and this one we can change. And we will change cross section for the stiffening member. Sorry. Let's add a new cross section, and now we won't use regular polygon, and that's the magic in this example, because we cannot connect directly to circular hollow sections as members, but we can help ourselves with this kind of cross section. So let's do that and set appropriate values for this cross section. And we can confirm. Now our cross section was created. To make it clear for you, now I will switch to transparent mode. And now I want cut member 1 by stiffening member 1. Let's add new operation, cut. We want cut member 1 by stiffening member 1, and the cutting method is by surface. And for this time, I will switch off the welds, because the welds will be added in the next operations. So now our connection is almost done, and now I have to connect these small plates one by one, because circular hollow sections are created from small plates, these ones. So let's add new operation, weld, and now we want, I have to switch to members because I have two members, and I want connect member 1, web 1 with stiffening member 1, web 1, and nothing happened because all of the edges of the plates are numbered. So I want connect this part of the connection, so there is edge index 2. So let's do it, and you can see this was highlighted, the weld was highlighted. So I can add for you the second weld, the same procedure, but now it's member 1, web 2 with stiffening member 1, web 2, and it's there. Of course, I will not do it one by one. I prepared for you the model before. So this model have been prepared for you. It's the same. You can notice stiffening member 1, cut 1. In the previous example, we added only 2 welds, weld 1, weld 2, and the same workflow is for another welds. It means you have to connect these plates one by one, and that's all. And I finished connection. I make for you some simple connection. I edit second or third member and I loaded it. And again, we received results and we can go through the stress, strain, mesh. Of course, you can change the inputs, or we can directly print the report. So the main thing for this second example is to choose cross-section for stiffening member. So stiffening member and make it as a regular polygon. It's hidden in the cross-section navigator called formed sections, and it's this one. So it's all from me. I can pass the word back to my colleague.
Thank you, David. Thank you, David, for your presentation. I will just tell you again the hints which is worth to remember. First of all, match the local coordinate systems of the members. It will help you in a further design, definitely. Then decrease the division of surface of the circular hollow sections, but only when there is no intersection of these circular hollow sections. Be careful about this. And another one, there is a really nice feature. If you input the negative offset of one or more edges, you can actually add a material and then easily cut it and adjust the shape. And the last thing, you can use the all operations without the parameters, which will help you to design a different thing than usual. So this is the end of the almost the end of our webinar. If you have some questions, please type it in. We will answer that. Probably not today because we are almost out of time, but we will send you the answers by email. And after the webinar, there is a really small survey prepared for you. Please fill it in. We will be glad. Recording of this webinar will be available tomorrow at our webinars in our webpage and in YouTube. You can get also your trial version if you are not signed it, and you can find really nice and a lot of stuff here in resources. The next webinars will be in the next month, in the March, and 6th of the March, we have another Connection Wednesdays webinar for StatiCa connection. This time it will be prepared and led by United Kingdom team. It will be multi-column base played by Arab. And then it will be followed by March 13th by our concrete team, and it will be about column with bracket according to ACI. So thank you, ladies and gentlemen, for your attention today, and I hope we will see you again in one of our next webinars.
So thank you and see you.
Bye.
Bye.